Through the last several lessons, we've really fleshed out our understanding of how to work through this case, and then sort of this entire picture is sort of our flow chart for how we do limits, right? We always attempt to evaluate the expression for the given input value, and then there are three possibilities. If that thing is a number, that's the limit. Right? If it's 0 over 0, we try harder. We've looked at lots of those. This video really focuses on this case over here. Right? When we evaluate n over 0, where n is not 0, so like 5 over 0 or 2 over 0, we know the limit doesn't exist, and that means there's a vertical asymptote. Right? But, in some sense, there are a lot of different things that does not exist can mean. One of the things that does not exist can mean is it can mean that there's just a jump. You have a function that's going like this, and then on the other side it's doing this. In that case, there's no... that limit simply doesn't exist. The two sides aren't coming together, right? But when you have a vertical asymptote, someone could argue that, let's say, as I'm approaching 1 over here, my function from the left is approaching infinity. Now, we can't really say it's approaching infinity, so it kind of does not exist, but when those things happen, especially if it's a one-sided limit, lots of times we consider that thing as an infinite limit, and we can say that in a very specific way, it does not exist because it's growing so large. So this video is really about sort of us exploring more specifically what happens when we have n over 0, and we'll look at several examples of that. So the trick here, the main idea is that, remember, when a limit does approach n over 0, it means there's a vertical asymptote. And if you think about it, like there's a couple things that a vertical asymptote can look like. It can either be an asymptote where one side is going up and one side is going down, right? Or, it could actually be the other way around, where, this side is that way and this side is this way. Or it could be a vertical asymptote where both of the sides are going up towards positive infinity. Or it could be a vertical asymptote where both of the sides are going down towards negative infinity. So the special thing that you notice here is that in all of these limits, the functions are either rocketing upwards towards positive infinity, or they're shooting downwards towards negative infinity. And all we have to do is figure out which one it is, right? So remember that from one of the previous videos, I sort of talked about the idea that when you have 1 over 0, you're more or less approaching infinity. And I should have said plus or minus, because we do need to care about what the sign is. And so I'm going to show you how we do that in this example, right? So in this example, we want to evaluate the limit as x approaches 3 from the left of this expression. Right? Now our trick is that we're supposed to, evaluate that expression for 3. Like we always just attempt to take the 3 and substitute it in for x and evaluate. So when I do that, when I plug in 3, I'm going to end up with negative 1 over 0, right? But really, I'm not actually plugging in 3. What I'm supposed to be doing is I'm supposed to be plugging in things that are ridiculously close to 3, but are smaller than 3. So if you were to plug in like 2.999999999, like really, really close to 3, what would we really get here? In the numerator, we would have negative something, right, divided by, and when I substitute in something that's barely smaller than 3, what happens in the denominator here? And don't I end up with a negative teeny tiny number? So this is like negative tiny. In fact, I almost want to write negative 0, but that doesn't really mean anything. The idea is we have something negative divided by a teeny tiny negative number. My final answer is going to end up being positive. And so in the choice between positive infinity or negative infinity, I'm going to pick positive infinity. And that is my limit, right? Now keep in mind, we could also say this limit does not exist. But if this was on a multiple choice exam, or on a free response question where they said, plus or minus infinity is acceptable, sort of either one of these answers could be correct depending on the context of the problem. I know I took a lot of time explaining this one. The further examples should be a lot faster. So I'd like you to pause the video, think about this one for a minute. Use the method that I just explained, where you sort of imagine substituting in a number that's approaching negative 5 from the right, and see what you end up with. So when I substitute in a number that's to the right of negative 5, so I have to think about what is to the right of negative 5. If you think about a number line, here's negative 5. If I'm approaching from the right, the value I'm putting in is like negative 4.999. So when I substitute that value in the numerator, what do I end up with? I basically end up with a negative something. Okay. What about in the denominator? When I substitute in my negative 0.499999 here, 5 is bigger than that, so I'm going to end up with positive tiny on the bottom. In this case, I have something negative divided by something positive, and that means that my final answer will be negative, and the only choice is negative infinity, so this limit is negative infinity. Again, keep in mind we could also say does not exist, but we can say more specifically than does not exist, it doesn't exist because it's approaching one of the two infinities. Now, we can also do this with double-sided limits, but the only way you can really do it is by looking at the two one-sided limits, right? And the idea is, we're trying to investigate for this problem, is this one of those limits where they're both going up towards positive infinity, or is it one of the ones where one's going up and one's going down? In this case, we could say, well, at least they're both going to positive infinity. Like, I guess the limit exists. But in this case, they're going to completely different infinities. Like, this is the most horrible infinite jump ever. In this case, it really, really wouldn't exist. So if you're feeling up to it, pause the video and try doing the two one-sided limits by yourself. If you need to see one example of this, there's going to be one more that you can try on your own later. So for this one, I will need to do the limit as x approaches 6 from the left of my expression, 2 minus x over x squared minus 36. And then I'll also have to do the limit as x approaches 6 from the right of the same thing. So if I'm approaching from the left, it means I'm plugging in something smaller than 6, just barely smaller than 6. So in the numerator, something smaller than 6, 2 minus something smaller than 6, that's still going to be negative. So I have a negative something over. Now, when I substitute in something that's barely smaller than 6, when I square something barely smaller than 6, I'm going to get something smaller than 36, which means I'm going to end up with a negative tiny in the denominator. So my final answer for this half of the limit is that it's approaching positive infinity. And for the other one, when I substitute in something that is larger than 6, my numerator is still negative, but my denominator, when I substitute in something bigger than 6, this is bigger than 36, so I'm going to end up with positive tiny in the denominator, which means this one will be negative infinity. Because these two limits are not the same infinities, this limit simply does not exist. So when you're working with double-sided limits that are of the form, in the very beginning we knew this was of the form something over 0. When you're working with a double-sided limit that's of that form, it just means you need to split it into two pieces and look at those two limits. If these two things had been the same, we would say it approaches that infinity. But because they're different, this limit does not exist. Okay, so on this one, I'd really like everybody to try this one on their own. Attempt to evaluate this double-sided limit, by looking at the two one-sided limits. So pause the video and do that. So our first step, as with all limits, and I know I've forgotten it on some of these, but we really always should be attempting to just evaluate, because we may be lucky. When I attempt to plug in negative 2, I end up with negative 3 divided by 0. Well, because I get this thing, I know that I now need to investigate. Is this negative infinity? Is it positive? Is it does not exist? That's the work that I need to do next. So I split this into two problems. I do the limit as x approaches negative 2 from the left of my expression. And then I'll also do the limit as x approaches negative 2 from the right. And from here, I'm going to use the same strategy that I've used before, where I'm going to sort of imagine that I'm substituting in a value that's barely smaller than negative 2. So barely to the left of negative 2, like negative 2.00001. Right? When I substitute that in the numerator, I'm going to end up with negative something. And in the denominator, it's interesting. When I plug in something smaller than -2, the inside of this is negative, but then it gets squared. So in the denominator, I have a positive, tiny value. Like that squared turns the negative into a positive. Negative divided by positive gives me negative infinity. So my left-hand limit is negative infinity. Let's check out the right-hand limit. Again, if you haven't already done this, pause the video, try it on your own. When I plug in something that's to the right of -2, the numerator is still negative, so I still have negative something. But in the denominator, when I plug in my larger than -2 value, the inside of this is positive, and when I square it, it stays positive, so my denominator is a positive tiny number, and at the end of this entire thing, we end up finding this is also negative infinity. Because these are both the same, we can say that this limit approaches negative infinity. And I know that this statement is a little bit confusing. You know, on the one hand, this does sort of not exist, but the reason it doesn't exist is because it approaches an infinite value. It's not like the previous problem where it just doesn't exist, it's not even approaching the same thing, right? So depending on the multiple choice question, the answer could be does not exist, or it could be negative infinity. So this is the procedure that we reuse anytime a limit approaches n over 0. Previously we would have just said, oh, you know, that does not exist, there's a vertical asymptote. Now we know a little bit more, and we can really look into whether this does approach one of the two infinite limits. So anytime you end up with this type of a limit from your initial evaluation, you use the procedure that we just talked about.